the first page. We'll do justice and get to the next page. So the first page that contains questions, normal, or you'll be reading final initial normal statements. Our interest is in A is a solution containing 0.04 mole per dm cube tetraoxide of a 6 acid. B is a solution of a high. Alright, welcome to Sir Majesty's World. So today we'll be taking a look at the titration between H2SO4 versus anhydrous sodium triisocarbonate 4, and what are the instructions given. This one is meant to be prepared by the teachers, containing 3.8 cm cube of the concentrated acid, while this is meant to contain 6.0 grams per dm cube of solution. So in 1000 cm cube of solution, there will be 6 grams in every 1000 cm cube of sodium triisocarbonate 4. Now the guide here is that this one is the easier one to find the strength. That is this sodium triisocarbonate 4. It is easy for us to find the strength of the sodium triisocarbonate 4. So it has 6.0 grams, of course. So to convert to mass, at least the molarity is equal to a mass given over molar mass, of course. So the mass is 6.0. The molar mass of sodium triisocarbonate 4 is 106, because sodium is 23, oxygen remains 16, and carbon is 12. So if you calculate Na2CO3, as we all know, is going to give us 106. So 6.0 divided by 106, maybe checking my calculator. Okay. 6 divided by 106 is 0.0566. 3 significant figure is advised. Okay. So our CB is automatically 0.0566. Remember to always put unit in case of calculations. These are the things that will help you secure mark without stress. Okay, now the focus is now what should be our endpoint. So the issue of endpoint now.
Wait a minute, have you heard about Sir Majesty Easy World? Guys, Sir Majesty took away my fear I had in chemistry and biology. You have to join the Easy World. My name is Victor Modia, a student in Italy. Anywhere you are, you can join us. Join the Easy World. Be a subscriber. Bye. Thank me later.
Hi, I wanted to tell you that you can contact Sir Majesty Easy World for your laboratory equipment and reagents. They are affordable and provide accurate results too. Sir Majesty Easy World only sells what he knows, and his patterns of delivery are sure and certain. Place your orders today. Thanks for your patronage.
Remember, why we cannot just say that there is one common endpoint for everybody here is that there will be different volume of pipette to be used, meaning different schools might use different volume of this base. In the other word, some might use 20 cm cube portions, some might use 25, but 25 is more common, of course. Secondly, the strength of this H2SO4, 3.8 grams, 3.8 cm cube of it, the concentrated. The percentage concentration of this acid was not specified. Yes, it is better like that to avoid suffering the teachers. So you're allowed to use any concentration you have, but not dilute. So at least you use the one with 97 to 99%. The most common one available, the ones I sell, of course, is commonly 98%. So, of course, there are determine molarity, you can know that one, but you can still use this titration to determine the molarity of the one you have in the laboratory. The molarity of most of the concave SO4 starts from 17 to 19.9 mole per dm cube. 19.19 mole per dm cube. This one is mainly for the one that is about 99% concentration, that's volume by volume. About 17 is already diluted a bit. Is very concentrated, sorry, don't mind me, but not usually in the so your own should be within this range. There are other ways to determine the molarity. You can use the SG and the percentage concentration. I've taught you these things on my channel here, so you search for the video and then go ahead with it. So for us to get the endpoint, there is this. From the practical experience, your endpoint is supposed to range from anything from 18.0 cm cube to even 21 cm cube. There is, remember that this is a range where you and your student can fall, not that these ones are all accepted in the same school. No. A student will be getting 18, another student will be getting 21. That is very far apart. One of them must be wrong, or both of them might be wrong, depending on the teacher's report. So remember, this variation is because of the strength of the acid H2SO4, though it's a bit stable, and again the accuracy of the burette and the pipette you are using. I sell all these things. I discovered that some of them have 0.2 cm cube error as you go down. Some will have even up to 0.5 cm cube error. So, but unfortunately, you don't test all these things. That's why you're advised to buy from us before we sell to you. It's not just being beautiful. It's well calibrated. Remember, there are faults sometimes, and these things are rejected. But they know that Nigerians are not all that too careful about analysis. For now, we are yet to. They will push it in here. So that's just the reality. And these are people that is pushing it, not that they are purposely pushing it. We go there, demand for it. So these are the variations. So you take 18.0 to 21.0 cm cube. Of course, always put your 0.00 in filling the table. So of course, that's it for the end point. So with the end point I gave you now, you can determine your own CA. So from the equation of the reaction, I'll give you the 4 likely questions in this guide, where they are coming from. Of course, it will not be above these 4 likely questions. Wherever they want, they will fall in any of them. So, but first, the equation of the reaction is, we are working with H2SO4 plus, I'm targeting the likely question 2. They might decide to treat this sodium thiazocarbonate 4 as hydrate, but I am assuming to do what we were told to do. So sodium thiazocarbonate 4 reacting with H2SO4 will give you automatically sodium tetraoxosulfate 6 plus water plus CO2, of course, as the basic product from the reaction. You'll be given the equation of the reaction. Sometimes you might not be given the equation of the reaction. It's possible. Whenever you are not given the equation of the reaction, it means that you'll be told to calculate for mole ratio, meaning from the formula CAVA all over CBVB equals NA over NB. This time around, if they don't give you equation, you are now going to be finding this mole ratio. Remember that this thing means that the whole thing here, when you multiply CA by VA according to this balanced equation, that you are going to get a number, that any number you might get something like maybe 8.5. Then when you multiply CB times VB in this type of reaction, because it's 1:1, you still get the same 8.5. So that if you divide 8.5 over 8.5, you get 1. And 1 means 1 over 1. And 1 over 1 means 1:1. But when you get 2 over 1, it means that the mole ratio is 2:1. What if you get 1.02? What's your ratio? It's still 1:1, because this is negligible. Do you get me now? What if you finally get something like 0.5 as your final answer? Just divide to get the fraction. Put 1 where there is point and fill other digits with 0. Remember your normal mathematics, converting decimal to fraction. So you now have 1/2. And this 1/2 means 1:2, just in case. This is the rare one. But if not, the equation of the reaction will be given to you. So I think these are the major guides you need, and you go through that likely questions. You can see I say we should focus more on the question number 2, where the anhydrous carbonate was treated as hydrated by the examiner. It's possible because they will hype the number. Remember, these figures I gave you here must not appear on your question paper. They might change this to mean another thing altogether. And this 6.0 gram you see here is not a must. This is for teachers. So you don't question them what they come finally with in the question paper. They might decide to make it 12 on that day, decide to make it anything they want. Remember, they say per dm cube here. Always check the solvent, the total volume of the solution, because if they say 6 gram per 500, that means 12 gram per dm cube. Okay, so endeavor to watch my videos where I solved these likely questions, because this is Her Majesty's Easy Word Science and I treat past questions. There are many of them, but these most followers just want to come and grab what they want, so I can't end up doing the same thing I've been doing before. They are there already on this channel. Like this particular titration, the number 2 I'm suspecting, it came out in alternative B WAEC 2024. So check my videos there. I have many solutions to likely questions. Then of course many experiments. I cannot do without you. Having seen someone like you, please don't go until you subscribe if you have not subscribed to this channel. And if you have subscribed, please share my videos and give us your positive feedback or even negative one. Try to give us ourselves. We want to see ourselves from you. I cannot see my performance unless from your reactions. So, but always make your statements civil. But we welcome your positive and negative criticism. It will help to shape us to a better level. Much love. Bye for now.
Wait a minute. Have you heard about the Majestic Table? It was designed and recommended by Her Majesty himself. Here it is. The amazing thing about the Majestic Periodic Table is that it provides a clear and colorful classification of elements, from P block metals to metalloids to liquid metals. It also shows the boiling and melting point of all the elements. It also has the unique feeling of electrons in the shells of each element.
To enhance the easy learning and teaching of chemistry in schools, in universities, secondary schools, in research institutes. So this Majestic Periodic Table, demand and special demand, as you can see that space there highlighted, that is where you can include the name of your school, or if you are dedicating it to anybody, you can write there, because you can print it to any size you like. In a majestic size, the resolution will never be affected. So it took me about 3 months to design and provide these informations, but thank God the table is here. What made me to design this is that I discovered that these tables I see in the internet, the one I see in the market, they are not as informative as I want. And then some of them are not updated. Some still retain the fact that we have, there are like, some still see promentum has not been radioactive. Some might see them as artificial element, but it is still is a naturally occurring element, of course. So there are some modifications that this table has been made to include, and that makes it majestic.